Fits. Yeah, welcome, the Eevee. Yeah, welcome to my presentation about Eevee and the next generation graphics for Blender 2.8. We saw so many talks in the last days, and everyone afterwards was coming to me and saying, we need Eevee, would you do a presentation, please, quick? And so I was literally preparing this presentation until the very last minute. So if there are slides that surprise me, you see my face looking like, what is like going on? And so I was trying to start with a nice picture of the viewport. That is currently the state of the viewport, and you see so many different demos and pictures in this presentation that I just don't want to bore you and start right off. So, who am I? I'm Thomas Beck, that's my Twitter account and the mail, if you'd like to mail me. I'm a CEO of Plasma Solutions. We do design, we do author stuff, so documentation for Blender and bringing out books. And the next book is starting to happen in 3 months or so. Then I'm creating Blender developer sneak peeks, but I'm only creating them if my son is not demanding to glue me a little lantern for him. So that is not that often recently. The topics of this talk are, what is this Eevee thingy? I think you know what it is, but I'm trying to give you a bit more insight into all that. Then why do we need and want it? Which features do we support? Which features do we plan to support? And I'll show you some demos and screencasts. Eevee is the extra easy virtual environment engine, which is not extra easy to say, but it is written on the web page, and I don't know if any of you just read that. How many of you know what was Eevee called before this slide? See? So that was exactly how it went with my presentation there. It is developed by Clément Foucault. He's outside somewhere, so if the talk goes well, then give him a big applause and a hug. And it draws the complete Blender 2.8 viewport. What that means will be explained in the presentation. Yeah. So we got a viewport already, right? Why do we need a new one, or especially Eevee? Because our current viewport is based on a fixed function pipeline. How many of you know what a fixed function pipeline is? Quite some. Maybe I should explain it. It is like, in the early days, you had some color intensities, and then you would write it into a big array and then send it to screen. That was easy, but it was very slow. Then graphics cards were introducing optimized methods for that, and then those methods were fixed into this GPU. And so those methods could be configured, but it couldn't be changed. And so the shader system that came afterwards was intended to just replace those fixed functions that you only had to configure by shaders. And shaders could be anything, even calculating or mining bitcoins, if you'd like to. More and more hacks and workarounds has been introduced into Blender, especially the post-processing panel. The post-processing panel in 2.79 has features like depth of field or some fancy other stuff, but the problem is that all those features are hacks, and if you'd like to do those better and even faster, then this wouldn't be possible with our current architecture. The legacy draw codes that we have in Blender are ancient, and foremost, they are performance bottlenecks. So when you got many polygons and you'd like to draw all them, then you'd like to stuff them into one call. That would be best, but that is all not easily possible with our current architecture, and so we need a new one. So let's first see what's possible with real-time engines. This one is Unity, and that is a movie from their YouTube channel. And I'll not play that completely. So that's it. That's a pretty cool demo, and it shows pretty nifty what is possible with the current shading model that we got in all our new GPUs. And when you see that, then this is rendered in real time, I think in 30 frames per second on a GTX 1080. So it's a consumer card, and that can render such things in real time. Typically, a Blender user would react like that if he sees this in another part of the software. And then it's followed by this, and mostly targeted at developers. And so most developers react like this, and then like this. But Clément didn't. So Clément was hiding 2 years in a cave and programmed so much. And he came up with Eevee, and we need new software technologies to implement such things. Because his Eevee development was forking Blender, and he was changing all kinds of stuff. And we then had to decide how we implement that all into our trunk, so into our master Blender. Blender 2.8 is a perfect catch for that, because with Blender 2.8 we said we can't rely on all this old technology, we have to remove things, we have to add new stuff. And so we said there is a new abstraction layer coming for Blender 2.8, maybe for Vulkan, but that is on the future horizon. The abstraction layer is capable of drawing everything very fast. And so the new minimum requirement for OpenGL is driving our graphics pipeline, is now 3.3 core, which should be supported by all graphics cards that came out after March 2010. Then there are viewport and render engines, and I don't know if you tried to read all the documentation that is online, but I tried, and it is really an overused word, engine. So everything is an engine, and especially in Blender now, everything is an engine. And so I'd like to explain what is this term. And the viewport and render engines are completely the same in the new Blender 2.8 viewport. So when you are hitting F12 later on, now it's not possible, when you're hitting F12, then the exact same engine is rendering your final render as the current viewport. And that is a very cool feature, because we then just don't have to develop two things. We just have to develop one and adapt it to the render time. And then an engine is drawing everything in its own way. So we have a specific task, like I'd like to have fancy shadows, and then I develop an engine for that. I'd like to have an object mode or an edit mode, then I develop an engine for that. And when the viewport, for example, is drawn by an engine, then you can take other engines and combine them together, so you can overlay, for example, selection outlines into your viewport. And maybe you've seen some of those demos that are on YouTube, where there is a cycles engine running and then a selection over top, and all those things are possible due to those mechanics. Performance optimizations can be done very easily when you have an engine specifically tailored for a task, and so this is possible as well. Every engine is a black box, so you give data in and you get data out. And when you'd like to implement a new engine, then this is easily possible. Just rely on the last one and do whatever you like. Our plan is in Blender 2.8 to have 3 engines. The Workbench engine will enable you to model. It should do that with nice, where's Ton, wireframes? With nice wireframes eventually. Maybe we implement a better system with auto-coloring objects or something like that, but we will definitely come to a solution that will please everyone in the modeling process. The next one is the clay engine. The clay engine is designed for fast sculpting and model previews and will feature nice cavity maps, cavity passes, SSAO passes, and so on. The Eevee, that's the PBR engine of Blender, is a high-quality engine. So the problem is, with all those real-time engines, you have to make compromises when you try to render graphics on screen, when you are a game developer. So most of the time, you'd like to have 30 FPS or 60 FPS, but we don't strive for this. We can just take a performance hit of, for example, 20 frames or something like that, because we don't strive for real time. We strive for high quality, very short render times. And so that is our engine. We have the metallic roughness workflow. This shader is already in 2.79, so if you used it, this will be no difference. We support real-time rendering. As I said, we strive for quality and have high-end features. And which features are presented by small clips that I prepared right before this presentation, so I hope they will play now. Our completed tasks are PBR and indirect lighting, where you can see it's easy to switch the colors, to switch between metallic and diffuse. Everything is live in the viewport, fast. You could have clear cool layers, which are specular or with a bit of roughness. And all those things you would expect from such an engine. Motion blur is maybe not that good visible in this presentation, in this clip, but it is enabled already, it is implemented, and we got very nice motion blur curves that we can tailor to our needs there. That is all live in the viewport. So that runs on my laptop with a 1060 graphics card in, I'd say, 20 frames per second. Bloom. So all this overdone effect in the internet, where you have those lights that are blooming, and I don't want to show anymore. It's possible and it works really cool. Depth of field. So if you've got several objects stacked together, then you can just enable depth of field, and you have a nice live view of this effect. Select an object, and you've got depth of field. That's this one. Screen space reflections, which target a specific problem that you're seeing in a sec. So there's a part here that is occluded by geometry, and if you'd like to have that back, then you can enable specific effects like screen space reflections. Then you see that this effect is coming through. Together with this bloom effect, it's quite nice. Then we got transparency and refraction. Just add a glass shader, and you're done. You could even have some roughness in there and then some effects like frosted glass. I don't know if I showed at the end, but let's just play it. Yeah. So it's pretty easy. Then this is volumetric lighting, all real-time in the viewport, but real-time, that's maybe a bit too across. It's running with 3 frames per second currently. So it's a lot to compute, but it's looking fabulously if you render it out. And one frame needed, I think, 4 seconds or so. So volumetric objects were just added 2 days ago. It's limited by the bounding box of the object currently, and what you can do with it is define spots in your scene where you have your volumetric effects. And normally you would do that by enabling it in your complete scene, but that is an extremely big waste of resources, and so you can now do it locally. And there are now smoke simulations which can be rendered, just like in the OpenGL viewport with super nice shaders. And I couldn't test it, but I trust Clément, who said it works. So maybe you should try it. And now what happens when you combine all those effects into Blender and open the super nice demo scene by Glenn Mellenhorst, then you've got this. So volumetric lights, screen space reflections, everything lit up perfectly with a PBR, with many PBR shaders, and everything in real time, more or less. So now we're coming to the development targets. And the development targets are always very interesting and at the same time very dangerous for us. Because when we say that this is coming, then you are asking if this is coming now or in 4 weeks. And so I can say the first half of 2018 will be focused on this. Subsurface scattering will be implemented maybe in the next week or in the next 2. So don't blame me for that if it doesn't. But Clément said so. The lazy shader compilation is currently a big problem when you load a file, because when you got many shaders in there, then it may be that your file loads up 20 seconds or so, and then 40 seconds, and then you think Blender has crashed, and then it's loading 20 more. So the problem is all those shaders are compiled before the user interface is reacting again. And then it's linking those all together, and that takes time. And with lazy shader compiling, you can just open Blender, open the file, have your user interface working again, and it's one after another linking, compiling and linking the shaders. So it's just a convenience thing. Frustum culling is for faster viewport updates because you're just discarding every object that you don't see. Open subdiv is super fast open subdivision by Pixar that is implemented by Sergey maybe. I don't know. Instancing, you all know what instancing is, or didn't you? Don't you? Okay. And hair drawing is self-explanatory. Then in the foreseeable future, that is then after the first half of 2018 until whenever, batch render and material previews should be easy to grasp. Ground to specular occlusion is a super nice specular occlusion method that is implemented by Clément. Then the viewport compositor is an amazing thing, because then we could have OpenGL renderings that are fed into the compositor, and when they are fed into the compositor, you've got all your nodes, you've got all your effects that you can apply to them, and then save them out in your pipeline. So that is an amazing thing. The shaded UV view is when you've got a model which is shaded in the viewport, then you see all those shading effects in your UV image editor, and that applied on top of your drawn image. Vertex shader material is a long thing, so we should just skip that. And, and parallax occlusion mapping and pixel depth offset is just to have a super nice depth effect that is very cost effective, because normally you would tessellate and then have all kind of stuff that happens on the GPU, but with parallax occlusion mapping and pixel depth offset, you have very fine methods to circumvent that and be faster. So, try it. There is there are those demo files that I showed on the webpage blender.org 2-8, and many of those Eevee features are really self-explanatory. Just open it, the render panel will contain all the options, play around with it. When you've got a crash, just play mouse. Thanks, and always plan on. That was it.